Hello all. Hello all. Hello all. So let us uh, discuss arrays in this class. So the basic idea of arrays are, so the concept is arrays. So it's a famous data structure that we use regularly. So what is an array? What is an array? So the array data structure is used to store multiple items together at one place, and these items are typically of same type, right? And these items are typically of same data type, right? So if you take the example, array of integers, so 10, 15, 20, 25, 30, right? So in arrays, elements are stored in continuous location. That means we'll call this as contiguous locations. So in arrays elements are stored in contiguous sorry memory locations. So the first element address x, and if size of every element is y, then second element is x, x plus y, x plus 2y, and it goes on. So for example, take the example. So consider the example having elements 10, 20, 30, 40. So the indexing starts from 0, 1, 2, 3, and so on n, right? So the first element address is x if the first element address is x, and if the size of every element is y, then the second element will be x plus y, x plus 2y, x plus 3y, and it goes on. So this is contiguous memory. So integers typically store 4. So say for example x is equal to 1000 location. So x is the address where array is stored. So y is the address, or y is the size of an array element. So for example, a is equal to array of 0, b is equal to array of second. So this would be x plus 2y, where we get big of 1 complexity for this. Basically, array elements are generally accessed by using their indexes, and these indexes start from 0. It starts from 0. The advantages of the array is the main advantages. The main advantages of the arrays is one, random access, second one, cache friendliness. That is, since the elements are stored at contiguous locations, we can get the ith item in big O of one time. That what random access is. So for example here, cache friendliness is, so cache is a memory which is closest to the CPU. So cache is a memory which is closest to the CPU, right? Because of which it is fastest of all the other memories, and these are the advantages while using arrays. Coming to the types, coming to the types of an arrays. Coming to the types of arrays, we have two types of arrays. One is fixed size, fixed sized arrays, which is static, and the other type is dynamic arrays. These dynamic sized arrays automatically resizes. Okay. Say for example, this is a fixed size arrays with index 0 to n. So here we have 4 elements, that means 0 to 3. So if you want to add fifth element with value 4, with value 4, then in static, that means in fixed sized arrays, it is not possible to add a new element. Whereas in dynamic sized, what happens is, if the array size is 2, the third element is trying, if we try to add the third element, then what happens? Automatically the size will be double. This is done automatically, the compiler. In C++ we have vectors to resize the arrays. Well, coming to declaration, how do you declare array? Integer. This is static. So this we'll call it as static allocation, right? For heap allocation, you can use in Java say for example in C++ for dynamical sized arrays we have something called as vectors. In Java we have array list. In Python we have list. So these three will be calling it as constructors. Okay. So in C++, the fixed sized arrays are allocated memory in two ways. So area in the stack segment, area in the heap segment. So where in area in stack segment, so these are locally stored variables. So for heap segment, so this is where you store dynamically allocated memory. Okay, dynamic sized arrays can act as fixed size arrays in this way. They have constructors like in C++ we have vectors, in Java we have array list, in Python we have list. So these constructors can specify the initial size of n elements. Okay, so in this way it works. So now let us see the operations on arrays by taking an example. So this is part 1. So in the next class we'll see part 2 of these operations with suitable examples. So let us consider example of unsorted array. So if the input array is with indexes 0, 1, 2, 3. So this is sorted array, right? So in this, let us do operation called as search. So search is an operation. So let us search x is equal to 5. Okay. So it has to return the output 1 because the 5 is present at indexed 1. If you take another example, say for example element is not present in the array itself, then what do we get output? So we should get output that is -1. -1 in terms of programming we'll call it as invalid input. So like that. Okay. So the solution for the problem, that is searching an element in a array, that is unsorted array. So let us construct the function. So let us take arguments array, let us take the size, let us take the element to be searched. Okay, let us traverse to array, that is from 0 to n minus 1 if array of I is equals to the element that you want to search. Okay, so if the element of I equals to the x, then what we want? We want to return high. So we want to return that element, else will come out of the if condition and will return minus 1, that is invalid. So this is a solution. So this will call it as a linear search. Okay. So the travel, if you traverse the array from 0 to less than that is n minus 1. So the time complexity would be, in worst case, it would be a linear. That means big O of n. Okay. So next, if we consider the next operation, insertion. Okay. If you consider the next operation, insertion operation. So let us consider the input. For the following input, so these are the empty spaces, but the size of array would be 5. I mean 4, 0 to n minus 1. So we wanna insert 7 at position 2. That means we wanna insert at this position. That means we have to move this 20 to a right position, and we have to insert this 7 in place of this second position, second index, right? So if you consider the other example, so the same, the index starts from 0, the size is 4, and I want to insert number 3 at position 2, the same position. So in this case, what we have to do, so we have to move this 20 to 4th index, 10 to 3rd index, and we have to place this 3rd to 2nd index, right? So the solution for the problem is so simple. So let us try the solution. Insert. So let us take the arguments. So let us take array first. Next, size of an array. Next, the element to be inserted. Next, the capacity. So we need capacity of an array because next position. So why do we need capacity of an array? Because say for example, we have an example like this array with 5, 3, 2, 1, 6 with no space at all. Okay, with size 4 from 0 to n minus 1. In this case, if I want to insert 1 at position 2, what happens? There is no space. This is a static array. This is not a dynamic array. But I want to insert. Then what happens? So as we have no space, so what it returns? It will just return a value as it is. So it will just return a n as it is, size of an array as it is. Okay. So how to construct this? So the base case would be if n is equal to capacity, okay, just return n. Okay. Next, let us take the index, that is position minus 1. Yes or no? So we need index. So let us store in idx variable. So let us traverse now for int so let us traverse in reverse way. So let us traverse from this point to back. Okay, let us traverse from n minus 1th position. So what we want? We have to move the array of I to array of I plus 1. So what we want? So say for example, so I want to move this 4 to 3 because I want to insert some 3 to second position. Then what happens? I have to move this 4 to third position before I insert 3 to second position, right? So because of which I am moving this index to I plus 1. So I am moving 4 to 3. Okay, this is the logic coming out. Next, update the array of index as x. Finally return n plus 1. Okay, so this is a simple solution. So in this case, you can say the time complexity is big of n. Okay, so at least in worst case, it has to travel the entire array or at least uh, two positions to a right side. So the best case would be inserting a 10 because if you insert a 10, you don't have to travel like move any elements to the right side. So if you insert a 10, the best case would be big of 1. If you insert at the beginning, it would be theta of n. Okay, it is linear. So in this way it works. So let us move to the next operation. So let us move to the deletion operation. So let us consider input. Let us say we have an array say for example I have x is equal to 12, so I have nothing, so I can't delete in this way. So let us consider uh, so let us consider 8 here. So let us consider 8. I want to delete 8 from the array. So the output, resultant output would be 3, 6, 10, 2. So I'm removing this from this place. So these I have to, these positions has to be adjusted. So this would be remained empty, right? So for this, the solution would be delete element. So the arguments that we want is, first we need array. The second argument that we need is the size of an array and the item to be deleted. Okay. So initially what we have to write. So let us declare I locally. So we need to traverse to the array. If the condition is if the array of I equals to x, so it is checking one by one. Then what I want, this should be the base case. I want to be break, okay, and I want it to be break. And the other case would be if I is equals to n. So we have then return n as it is. Say for example, each element. So we have 4 elements, right? So if the I is equals to n, then I just want it to simply return the number of elements to be 4. Okay. Now let us traverse for int. Let us take j is equal to I, j less than n minus 1, j plus plus. So here the solution would be array of j equals to array of j plus 1. So you want to put the j plus 1, so you have to rearrange. So the elements are arranged like this, right? So we have deleted this item. So these items should be filling this gap. So that's what we are doing here. So finally return n minus 1 element. So in this case, if you see here, the time complexity would be theta of n. It is a linear time complexity. Okay. Finally, we have one more thing. So let us finish now itself. So let us find the largest how to find largest element in an array. So let us not consider naive approach. So let us directly dive into the efficient approach. So the simplest way is, so let us consider the input and output first. So for the input, say 10, 5, 28. Okay. So the output should be 2. This is indexed. So 0, 1, 2. So at index 2, we are getting 20. Okay. So this is how we are getting. So we have to search an element, that is largest element. So it has to start from 0th index. It has to compare this element with this. If this element is not greater than this, and it will go to a next element. Say for example, this element is greater than 5. So then it has to store this element somewhere, or we'll call it as a buffer element. So finally, we have to return this particular element. Say for example, initially we have declared some variable, so make it as a result. So initially we have declared it as a 0. We have initialized the element, result element as 0. So when we traversed this, so we are comparing each and every element, right? So if the result, so initial value is 0, so it compares 0 with every element. So it comes, say for example, initially to result is updated to 10. So then next traversal, it travels to the array and it compares the value with 10. If the value is greater than 10, then it gets updated. So the value is 20. So it keeps on updating the result variable, and finally if we declare the result, that is a solution. So let us write the snippet code. So let us construct this get the largest function. So what we need is an array. Okay. So what we are doing initially, we are assigning the result variable with 0. So we are traversing to the array from 1 to length, arrays length. Okay. If array of I is greater than array of result, what we want? We want result to be reassigned with this I, and finally return the result. That's it. So in this, the time complexity is again linear, so it would be theta of n. Okay. Okay, that's all about the today's class. In the next class, let us solve few problems on arrays so that you get thorough on this topic. So if you have any queries, you can contact our team. If you are interested in joining our courses, you can download our application, that is Dean Global AI. For queries, you can contact deanglobalai@gmail.com. Okay, thank you.